Welcome everyone to today's webinar with Gorm Heron and guests Mitch Isles and Martin Cornelissen. Gorm, the floor is yours. We encourage all attendees to ask questions in the Q&A for discussion during the live webinar.
Thank you, Lauren, and welcome everybody. Today we're talking about AFFF clean out of fire vehicles and systems, and it's quite a different topic from what TRS normally is known for, right? In situ thermal remediation. But we're hoping to be a player in this, and we have two amazing guests today. Mitch Isles, who's a fire captain at Dallas Fort Worth, and Martin Cornelissen, CEO of Cornelissen in Germany, and one of the inventors of a method for cleaning these vehicles. To frame it up real quick, I just want to make a couple of definitions. AFFF, what is it? Aqueous film forming foam. It took me a little while to remember the definition, and even worse, the Pfas, what that is, per and fluoroalkyl substances. Mark will repeat that definition, but it took me longer than expected to get these. But AFFF is this foam that can put out fire very effectively, and it has Pfas in it. So if we're talking about banning Pfas use in firefighting, there are so many vehicles at airports and cities that need to be cleaned out. We estimate about 7,500 of them, and they're spread all over the US. And of course, the US is only a small part of the world. So what a task to find a cure for the AFFF, right? The AFFF is inside all these vehicles, hard to get out. And in a few years, we can't use them anymore. How can we do that? So this webinar, you can kind of see it as a parallel to a COVID case. We have all these illnesses that need to be cured, or all these patients that need to get vaccinated. Do we have a vaccine? Is it safe? Does it work? And if it is it going to be approved? Will the government start to pay for it? And how are we even going to manage all that? 7,500 vehicles in a few years. How do we get that done? So that's, of course, something I'm not clever enough to answer. So I have these two amazing guests. And we'll start with Martin, if you don't mind introducing yourself briefly, and then talk to us a little bit about AFFF and what it's used for, its toxicity, and and why we have to stop using it, please.
Thank you very much, Gorm. Before I start, I would like to say thank you to TRS for inviting me to this really interesting webinar as a speaker. It's an honor for me. Thank you. I just like to introduce myself briefly. I'm Martin Cornelissen, coming from Germany. I'm specialized in the field of water treatment and remediation technologies. For more than 15 years, I've been intensively involved in the purification of Pfas contaminated water, carried out several research projects on Pfas, and have also developed several technologies. One of the technology I've developed is a so-called Preflight method. This was originally developed for Pfas treatment in water, but since several years, we use this for the clean out of Pfas contaminated surfaces as well. Yeah, but I think we will surely come to this point later. Now, I would like to answer your first question, Gorm. Pfas are a class of substances with more than 5,000 individual compounds. The bad news is that 600, maybe 800 of these compounds are still produced and used in various applications, including AFFF foaming agents. And another bad news is that analytically, outside of scientific research, is only about 30, let's say 40 of these Pfas compounds can be measured so far. This means the most of the Pfas compounds are not detectable at all. And the measurable Pfas compounds are therefore can only indicate the total PFAS contamination inside the truck or inside water. Yeah, so my opinion is that we should use the best available technology for the cleanout process, because we find only a small part of the whole contamination. Yeah, next slide, please. I think I have to deliver a lot of bad news at the beginning, because I have to highlight that the perfluorinated PFAS compounds, the so-called PFAS, are considered cancer-causing and also mutagenic. Yeah, it's really bad. And in addition to that, the perfluorinated substances are released into the environment. They are absolutely stable, or let's say persistent. There is no way to biodegrade these substances under natural conditions. Yeah, so, but a positive message is that, as we all know, the PFAS has special characteristics, such as they have a high thermal stability, high chemical resistance, they show surfactant behavior, and this is exactly why these substances were developed approximately 70 years ago. But 70 years ago means 7 decades of releasing these compounds into the environment, and 7 decades of bioaccumulation of these compounds in, as well, human body. So far, we know not very much of the effects of these PFAS substance for the human health. But I like to summarize that this substance group is a very, very critical class of substances. So this is just a brief introduction in this substance group.
Very good. Thank you for that, Martin. So, I would love for you, if you don't mind, to introduce yourself and tell us a little bit about what it's like to be a fire captain at an airport and what you use there.
Sounds good. Well, yes, as Gorm said, my name is Mitch Isles. I'm a captain for the fire department at DFW Airport. I'm currently assigned to DFW's Fire Training Research Center, or the FTRC, and I manage and conduct our training for aircraft rescue firefighters from all over the world here. It's something that we're really proud of here at DFW, the FTRC, and being a training captain here at DFW has really broadened my horizons as far as ARF is concerned. I get to see a lot of people from all over and how everybody functions, but it's also given me an opportunity to learn more about things like the issues that we have going on within our industry, such as PFAS and the AFFF swap outs that we're currently working towards. So yeah, I really enjoy working at the airport a lot, and it's a good place to be. So I think trying to follow up on Martin's good news that he just gave us with how great PFAS is. It's definitely something to think about, the amounts of what we have at airports and where it can be found and those kinds of things. And that's something that we've talked about, a lot currently coming up to this, but at the airports themselves, you can find foam and AFFF specifically in a lot of places across an airport. So it really depends on each individual airport. Each airport may have AFFF or other fluorinated foams in different places, like hangar suppression systems, fuel farm suppression systems. But the only place it's really guaranteed to be found is in the ARFF vehicle fleet. So the FAA still mandates that AFFF is used as of now. With the Reauthorization Act that's going through, that, I mean, it's something that they're working towards finding another option for us, obviously. But right now, that's where it is. It's in the vehicles to use for firefighting. So if you're at a certificated or indexed airport, you must carry AFFF in your vehicle. The amount that is mandated at each airport for compliance is determined based off of the airport's index. So index determination is based off the length of aircraft at the airport and the average daily departures. So for example, the largest airports in the US are an index E, which means that they have aircraft that are at least 200 foot in length. And this is important because it coincides with the firefighting equipment and agent requirements that the airports have to have. So, so an Index E airport is required to have at least 3 ARFF vehicles carrying at least 6,000 gallons of water in the commensurate quantity of foam. That's the terminology that the FAA uses. So, and basically that means that that the truck has to carry enough foam to go through 2 tanks of water while discharging the water foam solution at proportioned at 3% without running out of foam. So that is the current use at airports today. In the past, you may have found it in more places, or it may have been used for different things besides just actual calls and things in systems. And like I said, some of those systems now can swap out to other types of phones. It's really only mandated directly in the ARFF vehicles themselves. But in the past, you could have found it in, for training, they would have been used. And you can show now, because most of the time, most ARFF training facilities have moved to propane systems, like what we have at our training facility. And these are controlled with thermocouples and sensors so that the training can be completed with water only, similar to what you see in the video here.
Can you show us just a few training exercises? How you use
Sure.
it? I know this is not where there's no AFFF used.
No foam used. It's propane and sensors in a lot of like I said in here. I think y'all have control of the video if you can play it. Yeah. So a lot of the airports that have training facilities, or the training facilities maybe that aren't at airports that focus on ARFF training, have moved away from using foam at all for a lot of reasons, but especially for environmental reasons. And so like here, this is a propane fire being extinguished with water only. And that's the way that it's really moved in the past, decades or so, essentially, to move to a propane type of trainer where you're allowed to just use water, and it uses, like I said, these thermocouples and sensors to simulate using foam so that we don't have to use foam. So,
but it's good.
And it makes pretty good fire too.
It's good to know that you have, you have a way to also test new things to see how effective it is, right?
Right. Yeah. And again, it's still effective. It's nice to be able to see. I think that's one of the things that we hope coming forward with the swap out maybe is that, what we hear from other countries that are already swapped, the fact that they can train again with their foam, they're not afraid to practice using their foam, and it gives everybody a better understanding as to the agent that they have on their trucks and how it works.
Yep. Fantastic. Thank you so much.
Yeah.
Then I have a question for you, Martin. Essentially, if you have to do a change out of one of these, I think Mitch has 8 or 10 of these Stryker trucks we just saw, right? How does it actually occur? What is our vaccine? How does that work?
Yeah, to answer this question, I would like to show you also a short video in advance which illustrates the perfluid process. The principle of action of the perfluid reaction is the precipitation process. It's not an adsorption, it's not an oxidation, just the precipitation. You see here the builded white flocks. These white flocks contain the perfluid, liquid active ingredient, which bound the formerly solved Pfas molecule in a weak ionic bound. And this weak ionic bound leads to a changing of the solubility behavior of the formerly solved Pfas and form flocks. And afterwards, after this reaction, we can easily filter out these flocks formed with conventional filter methods. Sometimes it's still enough to use a lamella separator to separate these flocks. So it's a very reliable and easy to handle a method. Next slide, please. Yeah, we developed this technology for the water treatment, but we have been successfully applied this method several years for the purification, also for the clean out of fire trucks. This video shows just the parking of the airport fire trucks on our site in Germany. And while the trucks are still being moved, I would like to start explaining the cleaning process you ask for, Gorm.
Yeah.
We divide the cleaning process of the fire trucks into 3 steps. The first one, and this is very important, is the emptying process of the system. It sounds trivial, but it's definitely not trivial. It is not enough to open just the drain valve. Yeah, we have to empty all components. That means not only the tank, but every pipe, every pump, every valve, and so on. It's a lot of manual work to do this. And it's very important that there is no AFFF foaming agent left in the system, because this will lead to a high Pfas concentration after the cleaning process. The second step is, next slide, please. The next, the second step is the flushing, the rinsed circuit of the system. We use fresh water for the rinsing process. We enrich with perfluid active ingredient. And this dilution we use to establish a cleaning circuit in every piece of the truck. Yeah, and we clean out using the perfluid coagulant and clean up the surface inside the truck. And the last flush in this step is always flushing without perfluid. We just use fresh water. And from this freshwater rinse, we take water sample and ship it to the lab and measure the Pfas contamination left. Next, please. Yeah, this picture shows a mobile perfluid cleaning station. We perform this cleaning service for fire trucks, not only on our own premises in Germany, but also using mobile installations on the premises of our customers, the fire departments. And this picture shows just one installation of these mobile ones. In front, you see a tank with some sockets and pipes and a control panel. We use this tank as a buffer tank. We put in the fresh water, we enrich with perfluid, and coming from this tank, we establish in this single components cleaning circuit. Next, please. Yeah, the final step is the treatment of the collected rinse water directly on site with a further perfluid application. That means there is no off-site disposal needed for the rinse water. Yeah, we have a separate step we use Preflight for and treat the water, the rinse water completely. And I want to highlight that we performed a lot of studies using ion exchanger and GAC and so on for this heavily contaminated rinse water. And I can tell you very often the background contamination, the DOC, the organic background load of the rinse water is so high that the use of GAC and ion exchangers failed completely. Yeah, the use of these materials could lead, I don't want to say in every case, but could lead to immediate breakthrough of the filters. Therefore, we use our Preflight step as the main process to clean out the collected rinse water.
Yeah, fantastic. We already have.
So these are this. Yeah.
Sorry, Martin. We already have a question come in that may be really relevant, and that is what happens. What happens to the water afterwards? What happened to, and what waste are you generating? So.
Yeah. We have a different kind of waste, but it's I can tell you right now the waste produced by the Preflight process, it's just a very small amount of thin sludge. Yeah, I always say it's not more than a cup of thin sludge we produced to clean a fire truck and treat the collected rinse water afterwards. Yeah, it's nothing compared to the AFFF foaming agent concentrate, which has to be disposed anyway. Yeah, and yeah, there is maybe sometimes we have to dispose the so-called first flush when we will receive fire trucks without a complete emptying of the foam agent concentrate. We have to rinse out with a small amount of water the AFFF remained in the system. This we called the first flush, and this first flush sometimes could be so heavily contaminated that we cannot treat it on site. And if this will happen, then we have to dispose this first flush off-site. But the normal case is that, sorry? Yeah.
No, sorry. I was just saying, I think that this is a good point. I just wanted to interject because I know from the fire side of it that there's a lot of people that don't, that aren't scientists, right? That are like, all right, what when I clean this thing, they clean it. I think they get it mixed up between cleaning the trucks and cleaning the rinsate. That they don't. They're thinking of it as all as one, and it's kind of two separate things, right? Cleaning the truck and cleaning the rinsate are two different processes.
Definitely. Yeah, these are two different processes. Yeah,
I think that's a confusion.
For one goal. Yeah. Okay. Sorry that I explained it not.
No, you did. I think your answer. That was my point. I think your answer answered a lot of those, though. That was my point. Was that going into this, many people don't see the difference between the two. Didn't know there was a different process for both. I think you're answering it in a way that does make that clear.
So we have two major challenges, right? One is to get these sticky chemicals out of the vehicle, out of the tank, the hoses,
right,
everything, and it absorbs, and there's potential for rebound. Even if it's one day, you come back the next day, it's diffused back in, like rebound in environmental contamination. So that's how do you get it out of there, and then how do you treat that without generating so much waste that you can't afford to even get rid of them. So Mitch, if this vaccine that we claim to have didn't exist, what would you do? Because you're going to be asked to change over all your 10 vehicles, right? In a year.
Right. We as we've talked about kind of previously in the past, the the biggest thing that we've seen so far, like I've reached out to a lot of departments that have already done these swap outs, and many of them are, obviously it's not in the US, it's in Europe and Asia for a lot of them. As far as trying to clean the truck, the only methods that we've really seen anybody try is a triple rinse, right? So trying to do the triple rinse because that seems to be kind of industry, at least for science purposes, standard of let's do the triple rinse and clean, and that's what's always been around. But to my knowledge, there was no testing after they rinsed to see PFAS levels left in the truck. They simply did the triple rinse and then loaded the new foam in. So there was no pre or post PFAS level testing. Many of the departments did this though, like over 10 years ago. And so much of the world, as we're seeing from looking at that, I'm like, man, they're a lot further along in this issue than we are maybe here in the US, as far as, moving forward with it. So the only data that I've seen from anyone regarding the cleaning of fire trucks is from the Melbourne Fire Brigade, where they created their 32-step process to clean their fire trucks, and they tested for PFOA and PFAS levels before and after each cleaning of each individual truck. And then, but I'm not sure if they did any testing after the testing was done at the completion of the cleaning though. Like I don't know that they went and tested for rebounding. They may have, I just haven't seen that data. So rebounding is a concern, obviously, that many of you are concerned about the scientists that I've spoken to. And so I'm not sure if that was done there. And then the only other group that I've seen any data from is Martin. Right, Martin and his group in Germany. And obviously he can speak to the numbers that he's gotten. So, but outside of the triple rinse and maybe those two processes and whatever other technology that's out there that I don't know about, I think many of them are like, hey, I'm going to rinse it or I'm going to replace it. So I know that the DoD and the FAA are working towards a lot of this research as well, to some extent, and hopefully we'll have more data from them to work with in the future. But I think that as ARF department leaders, they're looking for viable cleaning process that can be done, and hope that we're not left to do more expensive options like replacing piping or replacing the tanks and pumps and proportioners and hose and nozzles, all the things that may be contaminated, or worse, replacing the truck completely. A complete replacement, obviously, that's starting to get pretty expensive. With any of those replacing any of that is going to get costly, obviously, especially depending on the number of trucks that you have. So
fantastic. So we have actually already have a comment, but it kind of leads into the next question I have for Martin. And the comment mentions that Arcadis has used this process and taken samples before and after, and that's just great news. As we talk about, this is one vaccine, if you will, for this problem. Of course, there will be other ways of doing it, and we can only speak, to the vaccine that we're talking about here. That is the perforad. So we realize others are working on this as well, and may have great results. So. But Martin, to the question about how clean does the water get, and will there be rebound? I know you've treated a number of trucks, and it would be great to hear.
Mm-hmm. Yeah, sure. On the very left side of this left diagram, I show you starting concentrations, which depends on the size, the type, and also the age of the truck, as well as on the type of the foam concentrate, and especially on the achieved level of emptying of this foam concentrate in the first step. So you see, we in this campaign we cleaned out 11 trucks from one fire station. and the starting concentration ranged from 5 to almost 800 microgram per liter total Pfas. That's on the very left side, these higher bars. And the concentration achieved after the Preflight cleaning ranged from 0.0 to significantly less than 1.0 microgram per liter total Pfas. This means we achieve elimination rates of more than 99%, sometimes close to 100%, showing on the right diagram. So I think it's not too bad. Yeah. So.
Mm-hmm. Awesome. One thing I realized we haven't talked about yet is how long these change outs take. Mitch, I know the Australian method you mentioned with like 32 steps, it takes more than a week. Is that correct?
I mean, that's from, I've had limited conversations with Mick Tisbury from Melbourne, who seemed to be the one that was leading the charge for them, I believe, there. And yes, it seemed like from talking to him, their process became more streamlined as they went, even though they added more steps along the way, but they got better at doing it. And it seemed like essentially the general gist that I got from him is that it took about a week to get through a truck.
Okay. And Martin, when you do it, how long does it take?
Yeah, it's similar. 1 week, yeah, for the whole process, emptying of the foam concentrate, cleaning out the left Pfas inside the truck, and treating the water on site. This is included in 1 week work. Yeah.
Fantastic. And we have one more question before we open up to the questions that have come in, and that's essentially, what does it cost to clean out a truck? And I know it's always flexible, depends on where it is and how many you treat and all that, but can you give us an idea of roughly how much it is compared to a new truck, for instance?
Yeah, the cost depends on several parameters, including the number of vehicles to be cleaned, the location we have to use for the cleaning, means on our own premises or on the premises of the client, type and size of the vehicles, and so on. Therefore, I'm definitely not able to name a specific price, but in general, it can be said for the cost on a new truck, you can clean at least 20 and convert them to fluoride-free foam. So it's much cheaper than a new truck. Yeah. So, but it's a lot of work, and 1 week work and a lot of equipment we need. So it's a little bit to do.
And just one another follow-up question. I think it is easy to confuse the treatment or the concentration of PFAS inside the fire truck after treatment, what has to come down to a certain level. We don't have a regulatory level, right? Martin, you're saying that can easily get under 1 microgram per liter, and you have many results under 0.1 or 100 parts per trillion. And there was a comment saying groundwater needs to get down to 70 parts per trillion. That's lower. But of course, you referred to what was inside the truck at the end, and then all the water that came out will be treated with perfluoride and with carbon. And when it goes to the sewer afterward, that concentration is going to be way below 70 parts per trillion, correct?
Yeah. Okay, I understand. The cleaning level of the rinsed water we treated on site, we can reach 0 at the end. That's not the problem. Yeah.
That's good. Thank you.
But I never can promise 0 for the clean out of the truck, because there could be some places with remaining concentrate in, or some bleeding, PFAS bleeding seals or whatever. Yeah, so it's which we cannot clean with a rinsing process.
Yeah. Fantastic. I think we will start reading some more of the questions that came in. One of them that was, I can't see who asked it right now, but it was a very good one. He said, so with 7,500 vehicles around, you know, and you claim you can do it, when it is now mandated and there is a deadline set, how are you going to do that? You know, how are you going to manage that? And lucky enough, I actually prepared just a couple of slides on that. So you have to think about how to service this market, if you will. Each dot is a vehicle that needs clean out. We believe it will be a combination of mobile treatment units, as the one Martin showed at their facility in Germany, that can go out to places where the truck can simply not leave for a while. A combination of mobile treatment centers that can travel around and get set up, and then some cleaning stations where you can be in a major area for maybe 3 years, and you can have the vehicles come to you. If you look at, for instance, major airports, air traffic routes, and population centers, these red dots could be where you would set up such treatment stations. And then to get your vehicles treated there, you know, if it happens to be set up near an airport, you just drive your vehicles over. If it's a city fire truck, it may have to come a little bit farther. And some of the ones that coming from out of the city may have to be trailered, but roughly 25 to 30 treatment centers would service all of the US. This is Alaska and Hawaii out here, if you wonder what they were doing, if it was just bad PowerPoint. But so one of each of these stations would look similar to this: 3 trucks or more being treated at the same time in these treatment bays. There'll be clean water and dirty water, clean water on one side, and we have our perfluoride and carbon treatment unit here for what comes out of the trucks, so that the treated water can be close to non-detect, as we talked about before it leaves, goes to the sewer. So the small amount of waste comes out of this as a perfluoride flocculant and then carbon spent, and then the vehicles would leave. And as Martin said, these treatments will take roughly 5 days, I believe it is, 5 days, to Monday through Friday, right? And of course, we need to come up with rapid testing, so we know by Friday afternoon that the fire truck can go home over the weekend and doesn't have to come back Monday for another rinse. So we have challenges that we don't quite have super easy answers to yet, but we're working on all that. So in order to change out the 7,500 vehicles in a period of, say, 3 to 4 years, we would need about 25 of these stations, and they would treat 2 to 4 vehicles per week. So that's what it would take. And then the mobile units would go out and service the trucks that just absolutely couldn't leave their facilities. So while we take a few more questions, I'm just going to put the final slide up as an advertisement for the next webinar on May 12th. I don't have to read it to you, but and Martin and Mitch, feel free if there's any of the questions you like to answer, just take over. Otherwise, I will try to find some to read out. One of them is, what type of personal protective equipment, or PPE, do you need to wear when you're doing one of these cleanouts? And it kind of relates to how dangerous are these chemicals, you know? So when you're doing it and the guys are standing on top of the truck shaking it, or, you know, what are they wearing? What type of PPE do they need to have on?
As far as like if they do the clean out, like for Martin's clean out, or are you talking about for swapping or putting foam in when we handle it at the fire truck? Actually, I mean, at the department.
Both of them would be nice to hear the answer to.
I mean, mine's a quick answer. As far as the industry, there's not really a set industry standard for, you know, for a long time. Nobody knew that it was really an issue, so there wasn't a lot of, you know, industry standard wise PPE set that you needed to to be able to reservice your vehicle. A lot of departments are going through and putting in SOPs within their each individual department to state how this is how we're going to do it or whatever. And it comes back mostly to our normal PPE that we would wear for any sort of hazmat type emergency, even if it's just our basic turnouts or whatever. But at least for a majority that I've talked to, departments that have created some form of SOP, there's eye protection, skin protection, breathing protection of some sort when they're dealing with the raw foam, the concentrate.
Yeah, and I can add when TRS does work at PFAS sites, yeah, we follow the OSHA rules, right? And we look up the MSTS sheets and we determine what level of PPE we need, level A, B, C, D. It depends on the situation and what we're doing. So, yeah. Martin, did you have anything on this for what your guys?
I can only mention that the perfluoride material is not a hazardous substance. We developed as a completely biodegradable chemical. Yeah. So it's not hazardous for people. Yeah. So we use normal suits. We don't have to need special PPE.
Okay, that's a good point. It actually affects another one of the questions was, are you not concerned that some of this perfluoride is going to be stuck inside your vehicle? And by you explaining that it's biodegradable, that helps answer the question. Same thing would be if you asked, so you're using perfluoride, you're putting another chemical in there. How are we going to find out that that's even worse than the PFAS? And then, and would it have gone through the carbon and so on? And answer that question that is essentially biodegradable.
But I like to add that I hope I mentioned this before, for the final rinse, we only use fresh water to be sure that there is no perfluoride left in the system. Yeah. Yeah, so I don't think there is any risk that this could lead to a reaction or bonding with other materials inside the truck. So the final rinse with only fresh water. That's the main point.
I see a lot of fantastic questions. Unfortunately, we're about out of time. What we normally do when we have more questions and we can handle is we follow up in something like 1 week or so, and we try to answer all the questions that came in writing. So because you've signed up for this webinar, because you're now in our database, we can see who signed up and what your email addresses is. We will do our best to answer the questions that we simply couldn't get to today. So any final thoughts before we wrap it up?
I kind of do, just in general. I want to thank you, TRS, for bringing up the issue of truck cleaning. I do think that it's something that gets overlooked within all of this right now, especially within AFFF departments, because everybody's so focused on performance of the new foam versus AFFF and finding what new foam is going to be used. That when we're looking at the whole problem in general, as far as what all needs to be done, sometimes figuring out what's going to happen with the trucks is overlooked. So I know that there are several chiefs that are out there looking at this from a whole national strategy standpoint, and the fact that you're doing this type of research and having conversations about this part of the overall issue is hopefully bringing to light for all of those bigger parts of the government and whoever's making the regulations to make sure that we're all looking at this holistically, because each part of the issue, it all, connects as one whole thing. So I think sometimes if there's a national strategy being put together, we're not really sure who's leading it. Having and pushing other problems to make sure that they all realize that like when you did your explanation of how you might get through it. That's kind of the first time we've seen our vaccination plan, as you called it, right? So how are we going to get through it all together in all the parts? I think is important for us to focus on getting one set person or one set group to say, these are all the parts and this is how we're going to do it.
Yeah, and we still have a bunch of questions to wrap it up. Maybe even is 1 microgram per liter going to be okay for clean out? I would hope it is. Martin has shown we can comfortably do it, and I would think that makes a lot of sense. Considering that these foams have been used for 70 years and now they will not be used anymore. If you get 99.5% of the mass out of these trucks, and then the small fraction left over the next couple of months or years will be a minute concentration compared to been used for 70 years. Hopefully that'll be acceptable, right? That we don't need to meet drinking water standards inside the truck, for instance, but these manageable levels, such as 1 microgram per liter of total PFAS, would be doable and be environmentally a really, really good thing. If they pick a very, very, very low standard, it could double or triple the cost of this, because now we can't do it in a week anymore. So let's hope for that, and then let's hope for when the ban on AFFF use is really enforced, that there's also some funding set aside for those who own firefighting vehicles. As we know, a new truck is 1.4 million. And if you can clean out 20 or 30 old trucks for that amount of money, you don't have to buy a new one. That would be a whole lot better. So
funding definitely is going to be a concern for those for the airports that are out there. That's what I was saying before earlier, like, am I going to have to replace pieces of it? Can I clean it, or do I got to get rid of the whole thing? And I think most of us are hoping for a cleaning option purely for cost purposes, if nothing else.
And the other part of it is, if you do retire vehicles with AFFF residue in them, you should still clean them out, right? Because you can't just send them to Brazil, sell them, and with all the PFAS inside. That's not ethical to do that. So even waiting 10 years and saying, "Oh, my truck is too old, I'm going to get a new one," is not the solution, because it still needs to be cleaned out at the end. So, okay, thank you so much for your participation and for the great questions. And we will end the webinar now. Thank you.
Thank you, guys.
Thank you.
Thanks, everybody.